Classwork 23. So the first one is solving the quadratic equation. Use the square root property. So the left-hand side is a perfect square, right? The right-hand side is a number. So in that case, we can square root both sides. We square root the left-hand side. We square root the right-hand side. But when we square root, we get two values, right? Think about a 4. If we square root of 4, 4 is 2 squared, and also is -2 squared. So there are two solutions. If we have x squared equals to 4, so x has two solutions, +2 and -2. And usually we can write as a +-2. So the left-hand side perfect squares with square root. Square root cancel each other. So we get x -2 raised by 1, which equals to positive or negative square root of 3. Then we move -2 to the right-hand side. Negative on the left-hand side to the right-hand side become positive. So we have two irrational solutions. One is 2 plus radical 3. The second one is 2 minus radical 3. All right, that's the first one. Second one, we want to solve this quadratic equation by completing the square. So first we see each term has 3 as a factor. So we can divide every term by 3. Then we get x squared minus 4x plus 2. Right? So now we want to complete a square. We take a look at the first two terms. So we focus on the first two terms, x squared minus 4x. So we think -4 divided by 2, which we get -2. Then we want to add -2 squared, which is 4. We want to add 4 and subtract 4. So we get x squared minus 4x plus 4. Then we still have these 2, right? So -4 plus 2, that's -2. Then these 3 terms give us a perfect square, x minus 2 squared. And this -2, we want to move to the other side. So get it equals +2. Now we have a perfect square on the left-hand side. We can square root. So we'll square root. Then we get a +-2 square root 2. So we get x minus 2 equals to ± square root of 2. Move -2 to the right-hand side. We get x equals to +2 ± square root 2. So we get 2 irrational solutions, 2 plus radical 2 and 2 minus radical 2. That's 2. Let's see 3. 3, we're focusing on the discriminant. Remember the discriminant is, we can use this dot to represent it, b squared minus 4ac. Let's see A. A, in this formula, ABC, we have ax squared plus bx plus c equals to 0. Right, this is kind of standard. So A is a number before x squared, which is 1. B is a number before x, which is 4. The C is a number by itself, but on the left-hand side. So the right-hand side has to be 0, because we want to put in this form. +1 on the right-hand side, move to the left, it becomes a -1. So C equals to -1. Now we plug into the discriminant. B squared is 4 squared minus 4 times A is 1 times C is -1. 4 squared 16. Minus 4 times 1, minus 4 times -1, positive 4. 16 plus 4, get 20. So this is positive. This is positive. And a 20 cannot be written as something squared. Right? So we have two irrational solutions. This tells us we have two irrational solutions. And we can even find those solutions, right? We have negative b plus minus, that's the discriminant, then divided by 2a. And we have a negative b is -4, plus minus square root of 20, divided by 2. -2 divided by 2, -4 divided by 2, -2. Plus minus, or remember square root of 20 can be simplified as square root of 4 times 5. Square root of 4 is 2, so it's 2 radical 5. So square root 20 is 2 radical 5. Then 2 divided by 2 is 1. So this becomes -2 plus radical 5 and -2 minus radical 5. So two irrational solutions. So that's for A. The discriminant is positive, but it's not a perfect square. Now let's see B. Same thing, let's figure out A, B, C. A is 3, B is -4, and C is -2, because we have to move 2 to the other side, become negative. Then B squared with a -4 square. I want to calculate discriminant. Minus 4AC, 4 times 3 times -2. -4 squared, 16. Minus 4 times 3, minus 12. Minus 12 times -2, positive 24. So we get 40. When we square root of 40, that's square root of 4 times square root of 10. So 2 radical 10. And this is positive, and it's not someone squared. So it's similar to 8. So we get two irrational solutions. Even one, we can find those two solutions. X equals negative b with a negative 24 with a positive 4, plus minus 2 radical 10. Excuse me. Divided by 2 times a, 2 times 3. So that's a 4 divided by 2 times 3, plus minus 2 radical 10 divided by 2 times 3. Right, 4 divided by 2, that's 2. So that equals 2 over 3 plus minus 2 divided by 2, 1. Square root of 10 divided by 3. So two irrational solutions. Now let's look for. So for, we want to graph those two quadratic functions. And we want to identify vertex, x-intercept, and y-intercept. Remember the standard form for vertex form is f of x equals to a times x minus h squared plus k. So h comma k is the vertex. So a is in the vertex form, right? A is 1. H is -1 because we have x minus h. So this is x minus -1. And the k is 4 because we have plus k, so k is 4. So the vertex is -1, 4. Well, let's graph the vertex first. So it's -1, 4. X value -1, Y value +4. And because A is positive, so we have upward parabola. Upward parabola, we won't have x-intercepts, but we do have y-intercept. Y-intercept means x value is 0. So we just have to evaluate the function at 0. So we have 0 plus 1 square plus 4. 1 square is just 1 plus 4 is 5. So 0, 5 is our y-intercept, 0, 5 here. So we have those 2 points, we graph upward parabola. By symmetry, we have this point too, upward parabola. So that's the graph. Okay. Because this graph goes away from x-axis, so we don't have x-intercepts. Now let's look at B. B, we have in standard form. In standard form, so how do we find a vertex? We do x equals -b over 2a. B is 8 divided by 2 times a is 2. So -8 divided by 4, -2. Well, then we need to find f of -2. F of -2 equals 2 times -2 squared plus a times -2 plus 5. -2 squared, 4. 2 times 4, 8. 8 times -2, -16 plus 5. So 8 plus 5, +13, minus 16, get -3. So the vertex is -2, -3. X value is -2, Y value is -3. So the vertex is here. And it's upward parabola because 2 is positive. Positive means upset, goes upward. Now need to find a y-intercept. Y-intercept means x value is 0. If x is 0, this is 0. X is 0, so we have 5. 0, 5 is a y-intercept. 0, 5. So this is a y-intercept. So we can graph, but we have to figure out how does this goes across x-axis, right? Because it goes upward. So it goes somewhere like this. Oops. Roundish. So we have to graph like a roundish. By symmetry, so the vertex, so this is a line of symmetry. So that means we also have this point. So on this side, graph something like this. But we need to figure out those 2 points, the x-intercepts. So how to figure out x-intercept? X-intercept means the y value is 0 or the function is 0. So the function is 0 and the 2x squared plus ax plus 5. Let's move 5 to the other side. Okay, so we can write it as 2x squared plus ax equals to -5. Then we divide by 2. So divide by 2 for every term, we get x squared plus 4x equals to -5 over 2. Now we want to complete square, right? Let me change my color. So x squared 4x. So I'm thinking, what is 4 divided by 2, which is 2. 2 squared, which is 4. So I'm going to add 4 on this side and add 4 on the right-hand side. And these 3 terms gives me a perfect square, x plus 2 squared. And how do I combine those two? Well, 4 is a divided by 2, right? So -5 plus 8, that's +3. I get 3 over 2. Now I have perfect square on the left-hand side. I can square root both sides. So I get x equals x plus 2 equals to positive negative square root of 3 over 2. Move 2 to the other side, I get x equals negative 2 plus minus square root of, well, let's multiply 2 over 2. So we get square root of 6 over 2. So how do we graph those two? So basically, square root of 6 over 2 is in between square root of 9 over 2 and square root of 4 over 2. Right? So this is 2 over 2, which is 1. And this is 3/2. Then minus 2. So minus 2, minus 2, minus 2. So then that number is in between of a negative 1 and a half. So exactly, that's this number in between. That's a negative 2 plus square root of 6 over 2. And the other point is negative 2 minus square root of 6 over 2. It's in between negative 3 and negative 4. Okay, that's it. That's classwork 23.